Sums and differences of rational expressions. Remember, these are a little more difficult, or maybe way more difficult in your opinion, than products and quotients, because we need common denominators now. The best way, I think, is to start with an example. So what if we had x plus 3 over x minus 3? Let me maybe write down here x plus 3 over x minus 3. And we want to add, subtract from that x minus 3 over x plus 3. Okay. So we need a common denominator. The common denominator for these two fractions is going to be x minus 3 and x plus 3. Okay, it's the least common multiple of these two. So in order to do that, I'm going to have to multiply this side by x plus 3 over x plus 3. And this is legitimate because that's really just multiplying by a factor of 1. Anything over itself is 1, right? And over on this term, I'm going to multiply this by x minus 3 over x minus 3. And now we have this common denominator of x minus 3, x plus 3, x minus 3, x plus 3. And what we get up here now is, remember, well, let's just write it all out. We'll get x plus 3 times x plus 3 minus, now we have an x minus 3 times x minus 3. And this entire thing now is over the x plus 3 times x minus 3. Okay, of course we're not done because we have to actually do all these multiplications. So recall we're multiplying binomials here. So we have to do our FOIL thing basically, and we'll get x times x is x squared. We get plus 3x plus another 3x is going to give us a plus 6x. We're going to get plus 3, multiply those together, we get plus 9. Then we're going to have a minus. Now we got to be careful here because we're subtracting everything here. This is our minus. And we're going to get this binomial times that binomial, which is going to give me an x squared. Minus 3x is a minus 6x. Minus 3 is plus 9. And all of that is over our x squared minus 9, right? A difference of squares here, two conjugate binomials. Okay, so if we distribute this minus sign into here, and into here, and into here, okay, it's going to basically change the sign of all of these. So we're going to get plus, a minus. This will become a plus, this is a plus, so it will become a minus. Now if we gather all our like terms, we get x squared minus x squared. So that's going to get rid of that. We're going to have plus 6x plus another 6x. So it looks like we have 12x. We have 9 minus 9, which is 0. So we just end up with the 12x over x squared minus 9. Maybe not what you'd expect for the result, but once again, we've got to get this common denominator. Would you like to see one more? I thought you would. Let's try one other one. If we get a new page here, there we go. Okay, at random selecting another one here. Let's do x minus y divided by x squared minus y squared. And to that we're going to add 1 over 2x plus 3y. Okay, so we want to factor, get a common denominator. So we're going to have an x minus y. Our denominator here factors into, it's a difference of squares. So we're going to get an x minus y and an x plus y. And then we're going to add 1 over 2x plus 3y. Now notice, hopefully, that this x minus y and that x minus y cancel. So what we really have now is just 1 over x plus y. You can do it without noticing that, but it's going to be, you're going to be carrying around some extra terms, and that means more algebra, more chances for mistakes. Okay, our common denominator is now this times that. So we need to multiply this one by 2x plus 3y over the same thing, 2x plus 3y. And this one we need to multiply by x plus y over x plus y. And what we will get then is 2x plus 3y plus x plus y, because now we can just join all the numerators together. The denominator is the same, so we just leave that as 2x plus 3y times x plus y. Okay, and if we simplify this, we have 3x's, we have 4y's, 3x plus 4y, and we can leave our denominator the same, or we can multiply it out. It doesn't matter how you want to do that. I'm not too much of a stickler on that. So we could just leave it like that. Okay, so main thing, get a common denominator, and then you can just combine the numerators. Thanks.